interesting exercise. If a and b are the roots of the equation t into x square minus x plus 5 equal to 0, and if t1, t2 are the two values obtained from this relation, then we have to find t1 divided by t2 square plus t2 divided by t1 square equal to what? So this is a given equation for which a and b are the roots. This equation further can be written as t into x square minus tx plus 5 equal to 0. So that is t into x square. Taking x common, we are getting 1 minus t into x plus 5 equal to 0. Now sum of the roots is negative b divided by a for the quadratic equation ax square plus bx plus c equal to 0. The sum of the roots is negative b divided by a, and the product of the roots is c divided by a. So sum of the roots, that is a plus b, that is equal to negative 1 minus t divided by t. T minus 1 divided by t, and then the product of the roots ab is equal to 5 divided by t. Right? Okay. What is the condition given to us? If t1, t2 are the two values obtained from this relation, let's simplify this first. It is a square plus b square divided by ab is equal to 4 divided by 5. And a square plus b square can be written as a plus b whole square minus twice of ab divided by ab is equal to 4 divided by 5. And now we are getting a and b in terms of sum and the product. As we have obtained a plus b to be t minus 1 divided by t, and the product ab is 5 divided by t. This can be further written as a plus b whole square divided by ab minus 2 is equal to 4 divided by 5. Taking this 2 to the other side, we get 4 divided by 5 plus 2, and this is equal to 14 divided by 5, right? And now let's put the values of these two over here. We get a plus b whole square, that is t minus 1 divided by t whole square, divided by the product ab, that is 5 divided by t, that is t divided by 5, equals to 14 divided by 5. So 5 and 5 cancelled out, and this is t square plus 1 minus 2t divided by t square into t equal to 14. So let's cancel 1t. So we get t square minus 2t plus 1 equal to 14t. That is t square minus 16t plus 1 equal to 0. So we are getting the quadratic equation in t, whose roots are t1 and t2, as what is given in the statement. So from here we are getting the sum of the roots as 16 and the product of the roots as 1, right? So from this relation we have got two roots t1 and t2, and now putting the values of t1 and t2 over here to get the required value. So this is equal to t1 cube plus t2 cube divided by t1 t2 whole square. And using the cubic formula, we can write t1 cube plus t2 cube as t1 plus t2 whole cube minus thrice of t1 t2 into t1 plus t2 divided by product of t1 and t2 whole square. And we have got the sum of t1 and t2 as 16 and the product of t1 and t2 as 1. So sum of t1 and t2 is 16. So it is 16 cube minus thrice product of t1 and t2 is 1 and this is again 16 divided by 1 square. So that is equal to taking 16 common, and 16 square is 256 minus this is 3. That is equal to 16 into 253, and when multiplied we get 4048 as the required answer. Alright, thank you.